Hi there, in this video we're going to continue our discussion of the derivative and rates of change. This is part 3 of our video series. This is example 4. So we want to find in part A the instantaneous rate of change of that function at x equals -1. So right away when I see that I have a negative and I have a square root, I'm going to try to see if that is okay to do. So the first thing is maybe I can find the domain of the function. So I have the square root of 7 minus 2x as my function. So I know that for the domain, I have to have the inside of the radical can't be negative. So even though x is negative, that might be okay, right? I just want the inside of the radical can't be negative. So I want 7 minus 2x to be greater than or equal to 0, since the square root of 0 is 0. And then solve for x. So subtract 7 from both sides, divide by a -2. Since I'm dividing by a negative, I had to change the direction of the sign. So this will be 7/2. So my domain then is the interval, everything that is less than 7/2, including 7/2. So -infinity all the way to 7/2 bracket. So when I see x is -1, that is part of the domain. So I'm okay. Sometimes it's important to do that because we may have something that is not in the domain, and so there's no work to do, but always double check the domain. So find the instantaneous rate of change. We know that the instantaneous rate of change is the slope of the tangent line. So we're gonna find, we essentially need to find f prime of x at x equals -1. And in the last video, we talked about three really, definitions, different formulas for finding the derivative, the instantaneous rate of change. So we have that f prime of, in this case, -1 will be the limit as h goes to 0 of f of x, so -1 plus h minus f of -1 all over h. So that's one definition, or the other one will be the limit as x goes to a, so as x goes to -1 of f of x minus f of a all over x minus a. So we can choose either of these definitions, so minus and -1, and work with those. So I am going to use, I prefer the first definition, but really either one should get you to the same answer. So the instantaneous rate of change for this particular function, for what was our function? F of x equals the square root of 7 minus 2x at x equals -1 will be, choose one of those definitions. And so I'm going to choose the first one. So f prime of -1 will be the limit as h goes to 0 of f of a plus h. So the square root of 7 minus 2 and -1 plus h. So -1 plus h minus f of x. So the square root of 7 minus 2 times -1 all over h. So let me just highlight here what I did, or make a note. So this is my f of a plus h, so f of -1 plus h, and this is my f of a, f of -1, using this definition. And so we simplify this. So let's distribute that -2 into the parentheses. So I'm going to have the limit as h goes to 0. Make sure that you have your limit there, right? If you don't have the limit, you are not finding the instantaneous rate of change. You're finding the average velocity, average rate of change, but we want the instantaneous. So the instantaneous, you must have that limit there. So this becomes the square root of 7 minus 2. Well, we're distributing that -2 times a -1 becomes +2, and -2 times h becomes -2h. Minus, what is this? The square root of 7 plus 2, right? Minus 2 times a minus 1 becomes plus 2. So this is the square root of 7 plus 2, which is the square root of 9, which is 3. So minus 3 all over h. And now, how do I simplify that? Well, I'm trying to find that limit. So if I just plug in the limit, right? Anytime you see a limit, plug in the value, we're going to have the square root of 9, which is 3, minus 3 over 0. So I have 0 over 0, so I can't do much. So that means anytime you get 0 over 0, that means do some algebra. And so what is the algebra that we do when we have a radical? We are going to multiply by the conjugate. So if that's what you were saying to yourself, yes, we are going to multiply by the conjugate. So I'm going to multiply by 7 plus 2 minus 2h plus 3, right? The conjugate of what's separating the radical in the next term. So that's a minus, so plus, and multiply top and bottom by the same thing. Remember, with simplifying the difference quotient, our goal is to eliminate this h from the bottom. So I will have the limit as h goes to 0. On the bottom, since our goal is to eliminate this h, I'm not going to multiply it in. So I'm just going to leave it as h times, and then that quantity, 7 plus 2 minus 2h plus 3. Now, what about my numerator? So I'm multiplying this quantity times that quantity. They're conjugates, so no middle terms. They get eliminated. So I'm going to have the square root of 7 plus 2 minus 2h times itself. So the square root cancel. So I'm left with just 7 plus 2 minus 2h, which I guess we can combine that to be 9. And then when you multiply, middle terms go away. So negative 3 times a positive 3 becomes minus 9. And so 7 plus 2 here is 9, minus 9. Those cancel. They give us 0, and so I'm left with, notice that I'm still writing my limit because I have not evaluated the limit. So I'm left with minus 2h in the numerator divided by h times that quantity. And now I can say, okay, h divided by h is 1. So we're left with just minus 2 in the numerator and that quantity in the denominator. I still have not taken the limit, so I still have my limit notation at the front. So minus 2 over the square root of 7. Well, let's just add those up. I keep writing 7 plus 2. 9 minus 2h plus 3. And now let's see, if I plug in h equals 0, there's only one h, so I'm going to plug it in there. So this becomes 9 minus 0, so it's just the square root of 9, which is 3. So this is minus 2 over 3 plus 3, which is minus 2 over 6, which is, what, negative 1/3. So that is the instantaneous rate of change of this function at x equals negative 1. So our function was the square root of 7 minus 2x. At x equals negative 1, the instantaneous rate of change we just found is negative 1/3. So that is also the slope of the tangent line. And in part B, we're being asked to find an equation of the line tangent to the graph at x equals negative 1. So let's work on that part. Since we already found the slope, we just really need to put it together into the equation of the line. How do you find the equation of a line? As soon as you see that your task is to find an equation of the line, then we should write ourselves our way of finding the equation of the line, the point slope form. Or you could also use y equals mx plus b if you prefer that method. This one, sometimes the points are not so nice, so this one doesn't work out as well. So this one I find it easier to simplify. So I prefer the point slope form for finding my equation of lines, but if you prefer y equals mx plus b, then you can do that. So find the equation of the line tangent to the graph. So in this case, we know already the slope. The slope of the tangent line is the same thing, that's equivalent, that symbol, to the instantaneous rate of change. And we already know then from part A that the instantaneous rate of change was negative 1/3. So we know the slope of the tangent line is negative 1/3. So I will know that much from my equation. So I can say, therefore, y minus y1 equals m, so negative 1/3, x minus x1. Always to find the equation of a line, you need a point and the slope. In this case, we have the slope from part A, so we need a point. How do we find a point? Well, we know that we're looking for the point when x equals negative 1. So when x equals negative 1, what's y? Y is f of negative 1. So just plug it into the function. So it'll be the square root of 7 minus 2x, right? So minus 2 times negative 1. So, and we found it earlier also that it was the square root of 9, which is 3. So our point x1, y1 is the point negative 1 comma 3. So now we can finish part B. So it'll be y minus y1, so y minus 3 equals m, negative 1/3, x minus x1. And just simplify it. Distribute the negative 1/3. So if you want to put it into slope-intercept form, so this will be y minus 3 equals negative 1/3 x minus 1/3, and then add 3 to both sides. Here you will need a common denominator. So we'll have, what's the common denominator? 3, so you're going to multiply this one by 3 over 3, so you're going to have negative 1/3 plus 9/3, so it'll be plus 8/3. So that will be your equation of the line. Tangent to the graph at x equals negative 1. So I know graphing calculators are not required in this class, but if you happen to have a graphing calculator, then you can quickly graph the function our f of x equals the square root of 7 minus 2x, and then graph the line y equals negative 1/3 x plus 8/3, right? Mx plus b. And you should see that the line only touches the graph at the point when x is negative 1. So that's what it means to be tangent. You touch the graph at only one point. And if you use the other definition, so a good practice will be use the alternate definition, f of x minus f of negative 1 over x plus 1, and then see you should get the same slope. So when you simplify it, you should end up with negative 1/3 as the answer for the slope. So one of the reasons I chose this problem is to illustrate that when you have radicals, the trick is to multiply by the conjugate in order to get rid of the 0 over 0, right? 0 over 0, when you are taking the limit, means do some algebra. With radicals, the algebra to do is multiply by the conjugate. All right, contact me if you have any questions.